NASA published the first James Webb images on July 12, 2022. Webb's initial photographs are beautiful and full of scientific information. In these photographs, what did the James Webb Space Telescope find? How are they better than Hubble's? How will these photographs help astronomers comprehend the universe? Let's start with NASA's initial photograph, SMACS 723. It's the telescope's most profound and brightest infrared picture of the distant universe. This photo is packed with information. Start with the image's brightest spikes. They're like the stars on our noses, our own galaxies. The galaxy cluster is 4.6 billion light-years distant. When the Earth was 4.6 billion years old, these galaxies emitted the light we see now. This picture has much more details. A galaxy cluster's mass bends background light. Albert Einstein's general theory of relativity predicted gravitational lensing in 1936. The galaxy cluster bends the light path from background galaxies. Because of this, we see pictures of faraway galaxies. Webb's photograph shows gravitational lensing in a new way. Brightest cluster galaxy with orange arcs on both sides. Lensed galaxies appear twice in the arc. Non-mirrored galaxies exist. Magnification makes some look stretched. The galaxies behind the cluster look nothing like our spiral or elliptical galaxies. They're clumpier and uneven. This slender arc shows the power of the James Webb Space Telescope. Hubble hardly saw this arc, but Webb does. They're probably star clusters in a distant small galaxy. The deep field has incredible features. Webb will be more sensitive to point-like objects than Hubble. Red galaxies dot the background. Webb identified oxygen, hydrogen, and neon in one galaxy's spectrum. Webb is the first telescope to reveal such details of a 13-billion-year-old galaxy, revealing our origins. Webb's whole deep field photograph is roughly the size of a sand particle held at arm's length. Error bars around each data point represent measurement uncertainty. The error on these readings is minor, considering they came from a single observation. The blue line is a best fit model that deduces system attributes. Spectrum analysis takes time. The identified peaks in the spectrum indicate water vapor, although less than predicted. The Southern Ring Nebula is a planetary nebula 2,500 light-years distant. NASA provided 2 photos of this nebula, acquired by NIRCam and MIRI. Planetary nebulas occur when sun-like stars shed their outer layers. This NIRCam picture shows a frothy nebula with visible shells. Orange indicates expanding molecular hydrogen. Blue haze represents hot ionized gas heated by the star's core. Webb's photograph of the Southern Ring Nebula reveals something long predicted by scientists. This nebula's brilliant star is very young. Astronomers knew a nearby dying star caused the Southern Ring Nebula. No telescope ever found it. Webb's sophisticated infrared helped. MIRI detected a fading star surrounded by gas and dust as the nebula's origins. Periodically, the white dwarf star expelled mass. Repeatedly, the star constricted and heated, ejecting gas and dust over thousands of years. The celebrity helped stir the material. Webb's photo offers unmatched detail. A bright-angled line looks to be nebula gas filament. Astronomers analyzed the light source and identified a distant edge-on galaxy. Many distant spirals enrich the vista, some little, dusty, and crimson. The 4th image in Webb's collection is an immense mosaic of Stephan's Quintet, a cluster of 5 galaxies. Although called a quintet, only 4 galaxies are close together, with the 5th in the foreground. This picture is Webb's brightest. It has 150 million pixels and 1,000 picture files. This picture shows young star clusters. Gravitational interactions may be seen pulling gas, dust, and stars from certain galaxies. MIRI caught shock waves when NGC 7318b smashed into the cluster. Red and gold outline the core pair of galaxies. Dust in galaxies and shock waves between colliding galaxies are different colors. In contrast to the blue and white hues attributed to near-infrared stars, picture professionals chose yellow and orange to show MIRI data differences. This picture can reveal how galactic interactions drove early galaxy evolution. Carina Nebula is the first set's most gorgeous image. This 7,600 light-year-away star-forming area is unlike the Southern Ring Nebula. Webb's NIRCam and MIRI captured this magnificent image of star nurseries. NIRCam's high resolution and sensitivity have revealed hundreds of previously unseen stars and galaxies. Newborn stars' radiation and stellar winds blow bubbles in cavities. Baby stars are also emitting golden protostellar jets. Hot stars on the image's upper rim push down dust and gas to form additional stars and planets. Radiation may dissolve gas and dust, stopping star and planet formation. In a manner, this image demonstrates how our solar system developed in a polar climate. The mountain-like formations emit ionized heated steam. Each building is 42 trillion miles, 7 light-years tall. A star forms in 50,100 years. This makes capturing early star formation challenging. With Webb's sensitivity and geographic precision, we recorded this unusual occurrence and expected more remarkable weekly sightings. Webb's first photographs showed the telescope's potential. We can't wait to see what Webb discovers next. If you like this video, like it, subscribe to our channel, and hit the bell icon. Never miss another.